Hey everybody, my name is Micah,
My name is Sebastian.
and we're going to be presenting our heparin calculator that we created using KNIME. When creating this calculator, we use the heparin nomogram, which is currently shown. To start, we're going to kind of focus mainly on that top section where it notes the initial bolus dose and the initial infusion rate. These values are what we will base our calculations off of. In addition, there are also a few important notes listed below just to kind of keep in mind as you're dosing these. Looking at the KNIME workflow specifically, you can see at the beginning there are 3 separate calculators, all corresponding to different nomograms. So we have the cardiovascular, the DVT, and the pediatrics calculator. We're going to look at the cardiovascular calculator a little deeper. So when you click into that, you are initially seeing, or you're shown 2 different nodes or 2 different components, one being the infusion rate component and the other being the post-APTT adjustment node component, excuse me. Going into the infusion rate component, the first node used are input nodes, which allow the physician to input the patient's current weight and the formulation used. In addition, that last node in that column allows the physician to select the unit of weight inputted, whether that being kilograms or pounds. The next node will kind of merge all of these inputs together. So depending on the unit the physician originally inputted, a conversion from pounds to kilograms may be required. So within this rule engine node, we can see that we have defined kilograms as 0 and pounds as 1. So if the physician inputted kilograms, it will follow that top pathway in this conversion node. It'll follow that top pathway and stay as the value inputted. If pounds were inputted, it will follow that bottom pathway where a math formula node is used to convert the pounds into kilograms. And the differentiation on which pathway it goes to is used by that K-switch node at the beginning. Lastly, the top pathway after the unit conversion component takes the previously inputted patient-specific data and calculates the correct initial dose using this first math formula node. When looking at the nomogram, the max dose that can be given is 4,000 units. So the rule engine labeled max unit limiter will make sure that no value calculated will go over this 4,000 unit limit. The next math formula node will convert the initial dose calculated from units into milliliters. The round double node is used to simply round the number calculated into a cleaner, more manageable number to use. The column filter node is used to display only the necessary information and in this case, the initial bolus dose in milliliters. That lower pathway acts in a very similar fashion, but it is calculating the initial infusion rate. The nomogram notes a max of 1,000 units per hour, and this max unit limiter makes sure that any calculated value does not surpass that limit. The column filter here will filter out everything and only display the initial infusion rate. Lastly, this data is all displayed using the tile view node.
Alrighty, this is Sebastian again. So now I'm going to be talking about the post-APTT adjustment component. And now I'm going to go over to and open the post-APTT adjustment. However, I do want to direct you over here to the heparin nomogram. You're going to notice this square is all about adjustments, and you're going to see that everything is divided up into how the patient's current APTT is. And so after doing the initial bolus and the initial infusion, 6 hours after the infusion has started, then per the nomogram, you're going to take another infusion time and adjust as needed. And so for that, we need to make sure that we know how to tell the machine where and how to process everything. I'm going to direct you over here to the initial starting point where you're going to notice the initial inputs, which is the current APTT, the current time in military time, the current heparin concentration, as well as the current infusion rate per the initial infusion rate. You're going to also notice this refresh button widget, which I'm going to show much later. However, that will refresh the entire function, and it really makes everything pretty easy. Over here, before we get into the meat of the program, you're going to notice a couple extra things, such as a data app header and also a text output widget, which uses HTML format in order to basically display some text. And I'm going to show and label all of that once we actually show the program running. Getting into the meat of the details, once the physician inputs all of the patient's information, then it gets merged convert it to into table row, which makes things easy to work with and converts it to a number. Then we go into this differentiation step. The differentiation step is labeled over here by the current APTT time in seconds that the physician measures, and it really corresponds to all of this section right over here, which is the patient's current APTT. You're going to notice in every single row, there's specific instructions as to what to do when the patient APTT is at a specific point. And we try to facilitate that and automate everything in order to make things work. I'm going to highlight this initial, pre-processing meta note, which goes from the range of 101 to 115 APTT seconds. To double check that, I go over here in the string input and make sure that my default value is 110 seconds for my current APTT. I'm going to zoom in over here to the 101 to 115 meta node, and it's right over here. Over here, you're going to notice a couple things that I want to start off by highlighting. This is the initial range filter, which filters everything out by the ranges of numbers. So over here, you're going to notice the lower bound is 101, and the upper bound is the upper bound of 115 seconds, which includes the decimal points. And over here, you're going to see that it's being filtered out by the current APTT. The very next node that I want to highlight is the empty table switch. Because we have multiple nodes that the program will be running, we need to make sure that whenever that it only runs through one section, and whenever it runs through the other sections, we don't get an error. And so we use this node called the empty table switch, where it says that if it does not go through, then it will create an empty table and not give you an error, in simple words. So since we are running this and it is going through this section, then we do see that we get green lights, and it's indicating us that it is going through and it's not giving us an error. Over here, we're going to notice math formula, and this entire section deals with the time conversions. Over here, going back to the original workflow, you're going to notice that the physician will have to enter current time. If I go back to the Heparin nomogram, you're going to notice that for the 101 to 115 section, they are supposed to check the new APTT time 6 hours after the current time. In order to facilitate that, we made this math formula conversion where once the physician enters the time, then it goes through this section where it will initially add, let me open this real quick. It will initially add 6 hours in military time. And if the resulting time is between 0 and 2400, then it will just continue. And this is done by a row filter where it will only allow values between 0 and 2400 to go through, while if there is a number that's higher than 2400, it will go through this row filter and then reset the military time if needed, if it goes over 2400. And it does this by subtracting 2400 from the original value in order to reset it back to 0000. We use concatenate in order to combine all of these rows, and then we convert things to string. Now, the value that we're mostly concerned about for conversion to string is this current time. The reason is we want to make sure that the military time is displayed always with 4 values, 0000, or anything in between to 2400. In order to do that, we use something called string manipulation, where we use the function pad left. We select the current time in military time, which the physician inputted, and we direct it to say that it has to have 4 values, as usually military time is shown. And this function right over here basically says that if there's any value that is missing from those 4 digits, it's going to be replaced by 0. That way, we always make sure that, for example, if it's 6 a.m., it's not going to be shown as 600. It's always going to be shown as 0600, if that makes sense. Going over here to these rule engines and these math formulas, these 2 rule engines will display a message. And the intent to this is to basically say that if the current APTT is between these two ranges, these two values, then it's going to display a message of no bolus is needed. And that corresponds to over here as adjustment bolus dose. There's 0 bolus dose needed in order to continue with any sort of changes. Same thing happens if you need to stop or continue the infusion, which is more applicable to the higher ranges of the APTTs. Over here in the math formula, we're adjusting for anything related to infusion rate, and the round double is there in order to fix any large numbers that can hinder the overall view of the physician. We ended with the end if node, which goes along with the empty table switch. These two go hand in hand, and they make things work in case there's an error or it actually has it go through depending on the ranges with the range filter. Now, that the same is what I showed you is basically applicable for every single node except the very last one, which I'm going to talk about in a second. Over here, you're going to notice the concatenate node, which basically combines and joins all of these nodes in order to go to the end where it's going to be displayed for patient view or physician view. You're going to notice two different rows, a row filter over here with where if I select it, it's excluding a certain value. And this is something that we are very proud of because if you're going to notice back in the Heparin nomogram, when the patient's APTT is over 150, you do not display any values. Instead, you display a lot of text. And this text basically gives the physician information as to what to do in case the patient's APTT value is over 150. We ran into trouble trying to find ways to display that and have it differentiate between displaying values and displaying actual text. So I want to direct your views to the greater than 150 APTT pre-processing meta node. Over here, excuse me, I'm going to go back and adjust the APTT to have it be greater than 150. So I'm going to just add 160 and I'm going to run it. And I'm going to go back to the node. Over here, it's currently going through the 150 node. And once it goes through, you're going to notice very, very few things. The empty table switches, which as before, as I mentioned, it makes sure that there's no error in case this range filter does not go through. However, you're going to notice this constant value column. We want to differentiate this specific range from the rest of it. And so we define and we replace the current APTT value with a string value named NA. It's just a very random variable, which is distinguishable from the rest of the other ranges. And so that way, whenever we go back to this section right over here, we can use these row filters in order to differentiate whether or not there's an NA happening or there's not an NA. Over here, you're going to notice that we're including everything using pattern matching of NA. And if you recall over here in the row filter, it's excluding everything that has an NA. That way, we differentiate between going through the 150 APTT meta node versus every other meta node. I'm going to start focusing on the 150 meta node ranges. After it gets differentiated, we also apply an empty table switch on both sections in order to make sure that we don't get an error in case this row filter fails to go through. Over here in this table creator, we individually selected and added every single message that is supposed to be displayed. Then we concatenate, we row filter in order to make sure that only one column is being displayed, and we display the message within a tile view. Same thing happens up here with this tile view node with every single variable that is being displayed. Now I'm going to show you the actual program. So I'm going to go back to the initial section where we have the cardiovascular calculator that we just talked about and went over. So I'm going to go over here and click interactive view, and we're going to be able to see the final product. Talking over here, Micah discussed how we created the initial rate and also bolus dose for the patient. Over here, we're going to put in a patient weight of 40 kilograms with a heparin formulation of 500 units per milliliter. And we're going to go ahead and click calculate. Over here, the program automatically converts it to milliliters and also milliliters per hour in order to facilitate everything. And over here, we have a small message displaying saying that you have to readjust after 6 hours. You can always click calculate, and this will be your reset button. Just so I can show you and demonstrate you the limitators in terms of the maximum units and also milliliters that you're allowed to use, I'm going to put a crazy number such as 1600. This is going to be limited as shown over here. The number isn't crazy. It's being limited by a specific value and a specific function. And I'm going to show you just for completeness, I'm going to go even higher, and the numbers are supposed to stay the same, therefore proving that the limiter works. Going to the section that I explained, over here you're going to notice current military time, current APTT seconds, infusion rate, and then the current heparin selection. I'm going to go ahead and select an infusion rate of 4, an APTT of 111, and a current time of, let's say, 2200. According to this, if I go to the heparin nomogram, if I'm at 2200, I'm supposed to go up 6 hours, decrease my my dose by, or my rate by 1 unit per kilogram per hour, and there should not be any bolus adjustments or any stopping in the infusion. Over here, you're going to see the results where we add 6 hours onto 2200 and we get 4 a.m. There's no bolus needed, and also we continue the infusion and we ask the physician to refer to the corrected infusion section in order to check the newest infusion rate, which is 3.2 milliliters per hour. Now I'm going to go over and explain and demonstrate what happens if the patient's APTT is over 150 seconds. I'm going to go ahead and click calculate. And over here, you're going to notice all of the prompts below. It gives you very, very specific and highlighted steps as to what you should be doing. This is demonstrated by the NA function, where we actually differentiated between giving us data and giving us text. And we believe that this can be really applied to a lot of different utilities in future KNIME usage. The other nomograms have very, very similar functions. They just differ by little differences in calculations and little nuances. However, the processes and the way that this was built is the same. We want to thank you for listening to our presentation, and we hope to see you soon. Thank you.